Hello everyone, welcome back. Today is the day 2 of Python development course by Tech of Net Services, and we have our instructor Mr. Harsh Pranjal. Let me state in. Okay, so I'll start.
Yeah, just give me a second. Yeah. So, good evening, everyone. I think I am quite audible, right? So, we are discussing yesterday about how to get the ASCII value, right? How to get the ASCII value of a character. So, did anyone research about that? Okay, so which function we are using to get the ASCII value of a character? Okay, so we use the function that is odd, right? Get the value of a ASCII value of a character while running figure. Yeah. See. Okay, so using odd, you will get the ASCII value of a character. See, if you insert more than one character, right? So it will throw an error. Odd accept a string of length 1, right? Odd only accept the string of length 1. Okay. See, last day we have discussed that to get the length of any iterable, I mean any container, any variable, just give length and pass the string, you will get the value, right? So we have seen these, right? Okay, so let's continue with the list. Okay, so we have seen that we can create list like this, right? And then again inside of this there are numbers. We have seen that this is known as a nested list. And okay, just quickly let me know the output of this. We use my list 3 and then use suppose 1. What is the output of this print statement? What is the output of this print statement and this one? What are the output of these two print statements? Yes, error for the first one and output for the second. We'll get 202, right? See, in this first one we get an error, and that's because we are trying to access the index 1 of the third index, right? And third index is containing only the integer 4. So integer does not support indexing, right? That's why we will get an error. See, okay, int object is not subscriptable, right? And for the last one, we just get the sum of those two values, that is this 200 and this 2. Okay, see, this is how you access the value of a list. This is how we access the value in a list, right? Values of list. See, for accessing any value, we use the indexing, that is using square brackets. And if it is an, do you have any queries? Okay. So if it is a nested list, right, or if it is a string, then you can use again the square brackets to get the specific element out of that, right? Okay. See, other than this, suppose I have a list uh, 2, and I want each and every element of my list inside this list, right? So see, if I have a value of a equal to 10 and we will do b equal to a, then if we will print the value of b, right, then we will get the value 10. See, we are getting 10 for the value b. Okay, so similarly, if you can do like this, my list is equal to my list, and if you print my list 2, then see, you will my list 2 is a get the elements from my list similar to this a equal to 10 and b equal to a, right? But there is a problem. See, generally what happens, okay, okay, so we have seen that a list store the uh, reference, the memory addresses of the elements, right? What happened with the integer and the string? The integer and the string stores the elements, right? Suppose this is integer a, this is storing the value 10. Okay, so if you are creating, if we are performing this, sorry, this b equal to a, what is happening? One new other memory location is created with the value, and this new memory location is initialized with a value 10, right? Value 10 is provided to this new memory location. Okay, similarly, and how can you confirm that these are two different memory locations? See, just print the id of a and the id of b. See, okay, so let's not this one. Suppose give it 11. See, we have two different memory locations. Okay, in the first attempt, in the first attempt, in this attempt, we are getting both as same memory addresses. Okay, so there is a catch in Python for that. Suppose if I will perform b plus equal to 1. Okay, and this is a shorthand method. It is similar to b is equal to b plus 1, right? Now if I will print the id of b, see, now we get the id of new id b. It means b is a new memory location. Okay, see, just observe this very carefully. What happened with Python? Okay, Python creates a table, right? In very basics, Python creates a table. Okay, and table has many cells, right? Consider it like this. Table has many cells. Okay, then there is some memory location where you have provided the value 10, right? This is the memory location where the value 10 is provided. Okay, so for storing this 10, we have a memory location. But for storing this a, the name of the variable, Python uses a table. This table stores a. Okay, this table stores b, right? uh, okay. So what happens? This A is nothing but this memory location. So whenever you have created, suppose if I only give it 10, right? See, if I only give the value 10 to B now, then in this also in this condition, the memory location of A and B is same. It defines that A and B are the name of the same memory location. This is how Python saves memory. If two variables are having same values, then no new memory is created for storing those values. Okay, there is no new memory block for containing the same value, that is 10. Right, there is no new memory block. Both A and B are accessing the same memory location. Okay, so this is how Python saves memory. See, observe this table. A and B are two different variables. They are not same. They are two different variables, right? But they are accessing the same memory. Okay, these also go for the suppose I have a string and I have another string with same value, right? And now if I will print the ID, see, see, okay. So for strings, we get two different memory locations, right? And if you will perform a copying value, we will get the same memory location. See, similar to A and B, string 1 and string 2 are two different, okay, are two different variables that are no, those are not same, right? But for saving memory, they are accessing the same memory location. Okay, so in this condition, if I will perform b is equal to b plus 1, it means I am doing something to the b value, right? I am performing some executing some operation on the b value. For this case, now it is necessary for Python to create a separate memory location for b to holding the value. Okay, to holding the new value. I think I'm yeah adding one, so the answer will be 11. Right now, instead of this memory location, b is accessing this memory location. No new variable is created. Same variable b is accessing now different memory location. Okay, this is how Python saves memory, right? So this doesn't apply to each and every interpreter or each and every case. Sometimes it happens. Sometimes there may be there may you get different IDs for both variables. Means both variables are assigned with the same values but different memory location. Okay, maybe there may come a certain scenario where 10 is assigned to some new memory location with the B, right? Okay, guys, just let me know if this concept is clear. Any doubt on this concept? How Python saves memory? Okay, no doubts. So, see, why I'm telling you these memory mappings for an integer is that there is something strange is going to happen with this list, my list 2. Okay, just leave this one. We will execute here. See, in my first run, we are getting two different values of two different memory address for the string 1 and string 2. In the second run, we are getting the same values. So this memory, what you can say that memory management or memory saving is somewhat dependent to the interpreter, right? Okay, so yeah, we have my list as value 2, 3, 4, 5, and we have my list 2 with value my list, right? See, if we print my list and if we print my list 2, we are getting same values, right? Now, in changing the value, suppose the first element from 1 to 100. Guys, just let me know the output of this print statement. This one. What will be the output of this print statement? Okay, so the output is similar to this output, but just the first value instead of 1, we will get 100. Yeah, Ranjit, that's correct. Okay, so we will get 100. Now, what do you think what happened with that my list 2? Again here, we are getting 100, right? But I changed the value of my list, not my list 2. But the change is reflected to also reflected to my list 2, right? So this concept is then again related to yesterday's concept. We have seen that we have seen that a list stores the values of a memory address of the values, right? So we have the memory address of the values inside this list. Suppose this is a memory address, then we have a memory address 2, then we have memory address C, right? It is a hexadecimal memory address, so it can be of anything, integer, letter, or alphanumeric. Okay. So see, we have created two lists, right? My list, and my list two. Both my list. See, I just told you that for saving memory, Python access same memory address if both are having same values, right? In this condition, just print the ID. Print ID of my list two and print the ID of my list. See what we will get. Both have the same ID. See, my list and my list 2, those are two different names, those are two different variables, right? But they are accessing the same memory address, means they are accessing the same value. See, this is my list 1 and this is my list 2, and both are accessing the same value, the same memory, right? So, if you change the value of this index number 0, then that value is reflected in my list 1 and also reflected in my list 2, right? Because they are accessing the same value, same memory address, right? See, if I will do here, see, if I will do my list 2 and then again I change the I mean the second element with the value 200, see, the value is reflected in both my list 1 and my list 2, both, right? So guys, each and everything coming from this point ahead, we are going to see many different data types. So if you are able to understand these memory mapping, how variables access memory to get data, it is very easy for you to, understand very complex topics, right? So this is the very basic which is going inside your machine, right? So so we have seen the problem, right? While updating my list 2, my list 1 is also updated. While updating my list 1, my list 2 is also updated. So we don't need these type of, right, what do you say, these types of problem. So for that, to overcome this, there is a specific function we are going to use. So suppose I have a my list 1 with the values right? And I have my list 2, my list 1. See, if we are again going to copy the values of my list 1 into my list 2 like this, using assignment operator, that is equal to, right? Equal to is also known as assignment operator. So, see, if we are going to follow this one, then again we will face this type of issues. Okay. So to overcome this, just use dot copy. Okay. Now let's see what we will get. My list 1 index 0 is equal to suppose 100, and let's print my list 1 and then print my list 2. See what we will get. See, we will get my list 2, which we wanted. We copied the value of my list 1 into my list 2. We are only updating the value of my list 1. That's why that update is only going to be reflected in my list 1. Okay. It has nothing to do with the my list 2. Just let me know if I will print the ID of my list 1 and ID of my list 2. Did we get the same ID or different IDs? Did we get the same IDs or different IDs for these two print statements? Yeah, both will get different IDs, right? See, both will having different IDs. And how this copy works? See how that copy works. See, when we use copy, a new memory will get created. Each and every element, suppose this is my list 1, this is my list 1. Each and every element, I mean the memory address, the reference of that elements were copied from here to here, right? From this location to this location. Each and every reference address will be copied here, right? And suppose this is your my list 2, this will be assigned with the new list you are creating, that is my list 2. This is how the new list will be created when using copy. Okay. So for variables, for data types like integer and strings, all these things were what you can say that monitored and maintained by the interpreter, right? But for a list, tuple and dictionary, we have to explicitly mention the copy, right? This copy notifies that we want a copy of my list 1. We don't want two different names for the same memory location, right? What happened? What was going on the first example? In this example, in this example, this same memory location is having two names, right? My list and my list 2. That is what is happening, right? But for by using copy, we explicitly tell the interpreter that we require new memory location for this, right? Guys, just let me know, is this concept is clear up till now, or you have any doubt? Guys, this one is a very important concept. Yeah, what is the doubt? Okay, guys. See, we have seen how new memory will be created. We have copy function are same as work in string. A copy doesn't work with strings, right? Let's see if I will do it with like tr1 dot copy. see what we will get. We'll get an error. Copy doesn't work with string, right? That is a very good question. So copy only works with the variables which are iterables. Iterable means that variable supports indexing. Okay, so for only for those variables the copy will work, right? Or there is one very specific technical term for indexing. Instead of indexing, you can say that copy will only work with the variables which are subscriptable, right? Subscriptable means you can break the variable, means you can access different elements inside that variable separately, right? That is what subscriptable means. Copy only works with subscriptables. Up till now, we have seen the indexing, right? There are many other data types in Python which doesn't support indexing. There is something similar to indexing, but not exactly indexing, right? Okay. So if you're taking notes, just mark this statement that while using copy, each and every memory address from list 1 is copied to list 2. Memory address is copied, not the values. Okay, memory address is copied, right? What I mean that suppose this is list 1 and this is list 2, and suppose this is some value. Okay, this is some value. So what happens while using copy? Suppose the address of this value is C. Okay, the address of this value is C. So C is stored here. Then again, there is some address. Suppose that address is D. D is stored here. While using copy, these are two different lists. Indexing values. Yeah, string is having indexing values, but string is not subscriptable. It is immutable in nature. We when we discuss the tuple, we'll see why copy is not working for string, right? See, we have C. Okay, some value, suppose 10 is stored here in string in my list 1, right? This is my list 1. So while using copy, what happens? It will create a D, and that value 10 will be stored here, right? And this D is referencing to some other memory location. This C is referencing to some other memory location, but they are having same values. That is what our aim is, right? For using copy, to get the same values inside both lists, right? See, there is also a catch while using copy. Suppose we have seen this right now. This is not entirely correct. Okay, let's discuss what is the loop in that. Suppose I have a list and it is a nested list. Suppose I have 100, 200. Okay, if I will do my list 2 is equal to my list 1, and just name it as my list 1, and we will use dot copy, right? And suppose if I will do, guys, just let me know the output of these. What are the output of these two print statements? What are the output of these two print statements? Yeah, so there are two print statements, right? So provide two answers for each print statement. Yeah, so the values for B won't change. Yeah, that's correct. Now let me know what will be the output of these two print statements. Yeah, for my list one, it will be not 1 2 3, that will be minus 1 2 3, right? We have changed the zeroth index of the my list one. Okay. Now there is a catch. See, in this case, the value of my list 2 is also gets updated. See, for my list 2, we are getting the value minus 1, right? See, while accessing the element of the first element, that is the zeroth index element in my list 1, that reflects correctly, right? But while accessing the element inside a nested list, then again the values were updated in both lists. Okay, so it is again having some difficulties in managing memory. I mean, this uh, what you can say exception arises while managing memories. Okay, what happens? Just take a quick look. Okay, see, I'm only explaining this one, right? Why there is a change in the nested list, right? Suppose this is a list, right? And this is our nested list. This is nothing but our nested list. Okay. So the memory address, this list is also having some memory address, right? Like this one, like this two and three. This list is also having some memory address. Okay. And this list is having some memory address, and we have seen that list doesn't contain the original element. It contains the memory address of the elements. So suppose this is the box which contains that 100. This is the box that contains that 200, and this is the box that contains 300. Okay. Now what is happening? The memory of this is stored in this list. Memory address of this 200 is stored in this list. Memory address of this 300 is stored in this list. Right? Again, the memory address of this list is stored in this my list 1. Okay. Suppose this is nothing but my list 1, right? And this is my list 2. So just in the previous example we have seen that while creating that C and D for the integer, what is happening right now while using copy, a new list will be created. A new list will be created, right? Suppose a new list will be created, right? And this list is also having three elements. Okay, the address of this list will be given to my list 2 while copying, right? We are copying the value of my list 1 into my list 2, right? We are copying the value of my list 1 into my list 2, and inside of this my list it contains another list, that is nested list, right? Okay, so while copying we have created the new list, right? For my list 2 it is a separate nested list, but this, this list is again accessing the value of the older elements, the older boxes. Okay, so any change in these boxes, any change in these memory locations will be reflected in this red string, the red list and this orange list in both nested lists, and that will be again reflected in my list 1 and my list 2. I know this is a difficult topic to understand, but just give it a try. Okay, so that's why what is happening here? See, inside my list, inside my list 1, what we have the memory address of this one, right? Memory address of this one. Suppose that is nothing but M1. Then we have the memory address of M2. Then we have the memory address of M3. Then we have the memory address of this nested list, that is suppose capital M, right? Okay. Now, now this capital M, this memory block is nothing but again a list. Okay. That capital M is nothing but again a list. So it again holds the memory address of this 100 and 200, right? Memory address of this 100 and 200. Okay. So while using dot copy, we have seen that we will get a memory address, suppose consider it as A1, a memory address A2, a memory address A3, and consider it as capital A. Okay. A1 is holding the same value as M1, the value 1, nothing but the value 1. Okay. Again, that A2 is storing the value nothing but value 2. Similarly, capital E is storing nothing but the list itself, right? Now, capital A in itself is nothing but a list, right? So capital A should contain the values of the copied 100 and 200, the copy we are trying to create, a copy that copied 100 and 200. But what we have seen earlier is that uh, in this copy, in this copy, what happens that suppose for my list 1, we have memory address M1, M2, M3, something like this. And for my list 2, a memory address A1 is created and the same value 1 is copied to this memory address A1, right? Similarly, A2, A3, and so on, right? This same value 2 is copied to A2. This same value 3 is copied to A3. Oh, sorry. Similarly, in this case, value 1 is copied to new memory address A1. Value 2 is copied to new memory address A2. Value 3 is copied to new memory address A3. This whole list is copied to new memory address A. This whole list, and that list is nothing new but this memory addresses. Now, while using copy for these basic elements, my list 2 is having new memory locations. But for the nested list, both M1 and both M2 are sharing the same memory addresses. That's why updation in one memory address is reflected in both, right? Okay, guys, just let me know if you are having any doubt, or should I repeat this one? Because this nesting concept is going to be used in many more different data types. Okay, okay, that's great. I think this is the first batch which gets this concept in one go. Okay, so see, to overcome this, whenever you are using okay, so whenever you are using a nested list, just use some other function. There is something else. So what is this line, this first line? We will discuss about that. Let's first see that we overcome that problem of updation. Yes, so now let's see. We overcome the problem that updation, each and everything inside. Now instead of this M100, we are getting something else, A100 and A200. some new memory location. Okay. Yeah, all nested list is sharing same memory location is not the correct statement. But see how this dot copy works. How this dot copy works. Okay, it creates a new list, my list 2 for you. It creates some new memory locations A1, A2, A3, A4, A5. Whatever number of elements inside my list 1, same number of new memory locations are created inside my list 2, inside the second list. Then one by one, each and every the value of each and every memory location, each and every value is copied to that created new memory locations. Okay, inside that new memory locations. So it is okay if you are using an integer or a string inside my list 1 and my list 2. Oh, we can see the exception in string also. So you if you are using integer or some primitive data type, something like this. But when you are using a nested list, what happens? Some new memory locations are created by dot copy. That is okay. This one is copied to this A1. That is good. This 2 is copied to this A2. This 3 is copied to A3. That is also good. But this whole list is copied to capital A, the new memory location A. Now, both M1 and M2, that is my list 1 and my list 2, is containing the same copy, the same memory location for this nested list. Only that is the problem. Within the list, will use same reference as the copied list. Yes, that is the correct statement. Okay, so overcome this, we use a function deep copy. Now, what is this? From copy import deep copy, right? So let me take some examples. Suppose this test.py we have. Okay, okay, just leave whatever written inside here. We'll discuss about these also in our upcoming sessions. Suppose you have a Python program, right? And you have multiple files. Some codes are written in file 1, file 2, and some code are written inside this test.py file. So you want to use whatever code written inside this test.py. Okay, you want to that use that code inside your another file like we are using inside this D2. See how to use that code. Just write from test import test, right? Just use the keyword from, then use the directory name, that is the file name. Okay, the file name test, then use the keyword import, then use whatever type of code you want to import, you want to use inside your code, right? So there are some files, predefined files, which are known as libraries, and this is how you import or include a library in a Python. Okay, let's discuss about it in deep. Suppose, okay, just in only in this. Okay, suppose I want to print, not in this one. Suppose I want to print the sum of whatever inside this my list, right? So we have something like my list 0 plus my list, sorry, my list 1, then again we have something like my list 2. Like this, we have to again and again write the same statement to get the or to try to get the sum. Instead of this, you can just do, okay, just not delete this one. Just do this. See what we will get. We will get the sum of each and every element inside this my list. Okay, instead of that list, I think it's using something else. Did we get 114? No. Mhm. Wait, wait. Do we have defined my list? Yeah, comment this out. Okay, just the output here is wrong. We didn't. Oh, okay, okay, okay. Okay, we will get the value 114 because we have updated the value of my list, right? Instead of 1, 2, 3, 4, it is now containing 100, 2, 3, 4, and 5, right? Yeah. Okay. See, okay. So what is the logic behind using this sum? There are some codes running behind this sum, right? Which is producing this the sum of these values, right? Okay, just hover over this sum and press Control, click the mouse, and you will get the code. Okay. See, there is some this big block of code is written inside here. Okay, this big block of code is written inside here, which is performing the addition for this list, right? And producing the answer, the result. So from to see, we have just seen that there is a code, and this code is written in some another file in Python. Okay, so to use these type of codes, this type of function to help us in performing our calculation or something else like that. Okay, we import libraries from outside. See, we are facing the problem here with the memory copying. That's why we import something from outside, right? From outside. See, if I will click copy, see, this is the copy.py file. This is the copy.py Python code. And this code doesn't only contain the deep copy, it contains many more things. Like, see, copy mutables. We have copy mutables. We also have the dot copy we are using, right? And we also have, there is an error handler. Yeah, deep copy automatic. There are many more things inside this file, but instead of everything, we are only importing whatever type of file we require. That is the deep copy. This is how you import from another libraries, from outside files, not only libraries, from outside files. Okay. Instead of this, there is one more statement you can use. That is, see, if I am implementing without importing, see, instead of deep copy, if you only import copy, right? It's not showing right. Now it will show the error. See, deep copy is not defined, right? Why? Because we are not importing the specific deep copy only. We are importing the copy, this whole file. We are importing this whole file, right? So while you import the whole file, you you use this syntax copy dot deep copy. What this syntax will do? It will tell the interpreter that inside this copy file, there is some piece of code written inside deep copy. Only use that specific code, right? So this is what you when you use import copy. So, okay, just tell me the difference. See, you can easily observe this one. While importing deep copy, okay, while importing deep copy, you are only importing this much line of code, right? Only this much line of code, only this much line of code. That is roughly around 50 lines of code. Okay. Now, yeah, that is exactly 50 lines of code. But importing copy, while importing copy, you are yeah, you are importing like 300 lines of code, unnecessary lines of code, which for which there is no requirement in your code, right? So always try to import the specific class, the specific variable or function you require. Okay, there is no need to import each and everything. I think if you guys are of Java, there is one. Yeah, there is one very popular thing, that is import java.util.asterisk. Okay, see, this is the import statement in Python. This is the import statement in Java, right? What it will do, inside some Java folder, there is some util named folder. Inside that util folder, this asterisk means it is importing each and everything written inside that util. Similar to this import copy, it will importing each and everything written inside that copy. Okay, instead of doing this, just import the scanner class that you need. Okay, just leave that Java one. I think this importing and from import is now clear to all of you. Okay, so let's move on. We have seen deep copy, we have seen copy. See, we have covered how to access the elements, we have covered copy. Now we will move to comprehension and enumerate. Okay, so list comprehension. See guys, list comprehension is a very you can say that interesting topic. You can play with all day long, right? We are going to discuss only some basic requirements here, right? So if you have any doubt of your own of some other code, okay, feel free to ask that. Suppose we have a list, it contains 3, 4, and 5. Okay, I just forgot to give one more topic, that is first the slicing, then comprehension. Okay, just remove comprehension for right. Spelling of slicing is wrong. Leave that. So whatever we are going to discuss now, it is known as list slicing. Okay. See, while we use mylist.copy, it is going to copy each and every element, 1, 2, 3, 4, 5, all elements inside this list, right? But I don't want each and every element. I only want up to from index number 0, sorry, 1 to index number whatever that is 3. Okay, only that many elements I want. Suppose there are, okay, so I only want these many elements, right? So for list slicing, to copy a specific part, only the specific part of the parent list, it's list variable, start the square brackets, write the start index, and up to whatever you want to copy, right? And just keep in mind, it covers each and every index starting from start, and it is not including end, right? It will start from start and it will end at end minus 1. See what I want to mean. See, if I will do my list and I will do list comprehension from index 1 to, the index 1 is 2, right? And index 5 is this 6, right? I want each and every element from 2 to 6. Okay, so for that, see what we will get. See, I will only get the element till 5, only these many elements. See, this is what I mean, that with the end is not included. It always start from start, okay, and go up till end minus 1. Okay, end minus 1, that is 5. The index number end minus 1. Okay, this 1 and 5 are index numbers, not values, right? So if I want 6, I have to give one more index ahead of that. Okay, now see, 6 is included, right? So if you have studied maths and you have studied that, what that topic is, relation functions that then you have seen many more these ranges, right, including the first index, but not including the last one, just before that one. Okay, it is also described as start comma end minus one. Okay, end minus one is included, not end. See, this is what list slicing is. So, see how we have, if you are giving an empty list slicing index, then it will copy each and everything. So just add one more thing. Default values means if you don't provide any value, that start is equal to 0 and end is equal to length of list variable, right? See, you can achieve the same output, sorry, by doing this. Start में 0 and the next one is length of my list. See, I don't know the exact length of, and I'm not going to count that, so I use directly the length method, right? And we get the whole list, right? Yeah, but skipping values. See, now see, other than this start and end, there is one more thing, that is jump. Now, what this jump is? So suppose I want each and every element of this list, but I want all the alternate elements. Means I want one, but I don't need two. I want three. Then skip the four. I need four, five, something like this. And use the jump to see. We get only the alternate elements, right? Get one, then jump by one, then get three, then jump by one. This is what jump value describes, right? See, so default value of jump is 1. See, if I will put 1, means it is not going to jump anything, right? And if I go to 2, it will jump by 1. Jump by 1 means that first take the value 1, then start jumping from 1. 1 and 2 is jumped, the jumping value is 2. 1 and 2 is skipped, then print 3. I mean take 3, then jump by 2, something like that. Okay? So, okay, my list. This one is a very big example. Okay, see, now we have seen we have a start, an end, and a jump. There is some, what you can say, boundaries. Okay, some bounds. See, if I will start from index 1 and I want everything until index 5, then I have to provide 6, right? And I want a jump of -1, a negative jump. See, providing negative values is all right. Okay, so I want a negative jump. See what we will get. We will get nothing, an empty list. Okay, and why we get an empty list? See, this is how this list slicing work. While starting from 0 and jumping up till whatever the length, suppose that length is in this case is 12. Okay, jumping up till value 12, you can see that from starting 0 and moving till value 12, the 2 jump is satisfied. It means from starting 0 and jumping by 2, you can reach 12, right? You can reach the 12th index. But from starting from index 1 up till index 5, are you able to reach index 5 while jumping -1. When you are at index 1 and you jump -1, that is you are going back, right? You are going in backward direction, and there is no end for that backward direction, right? Okay, so because we have provided the start index as 1 and provided the end index as 6. So while it is moving backward, it is never going to get the index value 6. That's why it will, you can say that it will go up to an infinite loop. We will see what an infinite loop is. So it will, you can see, imagine something like a number line. It will go till minus infinity. Okay. So that is not a valid statement. That's why we will get a empty list. Okay. Something like this also. If I want to start from index 6 and I want each and every element till index 1, what we will get? So again we will get, just let me put in two different print statements. So again we will get an empty. Why? We are not defining any jump, right? And by default the jump value is 1. So tell me one thing, when you are starting at index 6 and you start jumping by 1, you will go till plus infinity, right? You are never going to reach 1. Okay, that's why we will again get the empty list. Sorry. Now see here. Now I will define a negative jump here. Now we will get the value, because it is possible to start from 6 and reach 1. Not exactly 1, we are going to reach 2, right? To reach 2 by jumping value -1. Okay, see, 76543. Okay, not the end is not included, just before end the first element, that is 3, up till this many, right? Guys, just let me know if you are able to understand these list slicing. Okay, just let me know the output of these two and we will move ahead. Sorry, I have played this one. Okay guys, what are the output of these two print statements? Yeah, so trust me, I am using Python for last 3 years. I have used Python for backend, for AI, ML, and many more. Instead of each and every list slicing, I have only used this one till now. Till date, I didn't, there is no requirement of using list slicing anywhere other than this reverse. Right, other than this reverse, there is no requirement of list slicing at all. Okay, so yeah, if you are into competitive programming, then you will require list slicing. execute this one. Yeah, now we have seen where are our topics. Yeah, slicing. Now let's see enumerate. So we are going to discuss a very important. See, guys, I am trying to explain each and every topic of a list in very detailed manner. I'm not going to explain each topic of tuple in this detailed way, okay? Or dictionary or string, right? Because each and everything, the concepts are similar, okay? See, we have something that is known as loops. First one is for loop, the second one is while loop. No requirement for do while. See, what is loop? If I will tell you that you have to print hello a total of 100 times, okay, then we will do this, right? This will print hello for a total of 100 times. And just put a space. And now it's better. Okay. Now suppose if I will give you a my list and there are, okay, let me generate something like this. Execute this. Okay, guys. Just suppose that this my list 2. Okay, just leave this first line. Okay, just leave this first line. Suppose that this my list 2 is containing a total of 100 elements. Okay, see, if I will print the length of my list 2, small l. Okay, let me just remove this one and provide it here. Yeah, now it's good. Suppose this my list 2 is containing a total of 100 elements. See, okay, sorry, 101 elements, right? Okay, and there is a requirement to visit each and every element. Okay, and suppose you have a question requirement that you have to increment each and every element by 1. Okay, so what does it mean that you have to do something like this? My list 2 index number 0 is equal to my list 2 index number 0 plus 1, something like this. Increment each and every value by 1. Okay, now instead of doing these many, see, you can see that while you are trying to do each and every by selecting the index, you have to do till the index number 100, right? So do we have time to write each and every index and update each and every value? No, right? So for this, we use loops. Loops. One of the very best example or one of the very good loop you are going to use again and again, that is for loop, right? So this is the syntax for loop. Let me write it in a comment. For this is the keyword variable slash reference name, okay, in iterable, sorry, or subscriptable, right? Then a colon, similar to if else statement, a colon, right? See what I mean. For a reference name I, okay, let's say element in my list 2, print element. See what it is going to do. I don't have these many spaces. Just reduce the value to 20. Now instead of 101 element, it is storing 21 elements. Okay, sorry, 20 elements. See, each and every element is printed here, right? 0, 1, 2, 3 till 19, right? So what it is doing, element is nothing but it is accessing each and every element inside this mylist 2. Means, suppose if mylist 2 is written like this, so whatever you will print using mylist to index 0, right? What we are doing? We are trying to access the value of this one, right? This one, index 0, that one. Similar thing is going to be done by this element variable. What this element is doing? It is visiting first this 1, then this 2, then this 3, then this 4, then this 5. Something like this. Each and every value inside a list is visited by this element. Okay? Okay. So see, in this case, again, the value of my list 2 is updated. We will only get 1 to 3. Yeah. So element is trying to access. See what happened. Element visits 1, then print the value of 1. Then element visits 2, then print the value of 2. Then element visits 3, then print the value of 3. Right? So what are our requirement? We have to, what you can say, that increment each and every value by 1, right? That was, yeah, that was our question. So no, I am written the wrong. There is a catch in this one. Okay. See, each and every value is incremented by 1, right? Now, if I will print my list 2, okay. Okay, guys, see, observe this one. Each and everything is written in a new line, okay, in a different line. If you want to write each and every element in a single line, okay, just use this one. After putting the expression, use this end, right? Write your print statement something like this. Then after printing the value of element, the print statement will not end with a new line. It will provide a space, right? See, it will provide a space. Okay, again, it is not that good. Use of print statement, I had to break the line. Now, see, these are the values which are printed by for loop, and the below one are the values of this my list 2. See, after incrementing each and every element of one element by 1, we are not updating the actual value of my list 2, right? We are not getting the actual value. What is the requirement? The requirement is to increase each and every element by 1, right, in my list 2, but we are unable to achieve that. Someone has written in the chat that it is, I think someone has mentioned that it was a reference, right? Element is the reference of my list 2, something like that. So element is not the reference of my list 2, okay, or the values of my list 2. Please note this one. Element is nothing but it is copying each and every single value inside it, okay, each and every single value one by one, okay. See, element first copy this one inside it, okay, then now you can do whatever you want with the element, but you are not affecting the actual one. the actual my list 2. You are not affecting that actual my list 2, right? Okay. So this is how things work for loop. This is the syntax. This is how you can access each and every element of my list 2. So still now we are not able to answer our question, the requirement to increase it by 1, but we have seen a new version of this loop, right? So guys, just let me know if you have any problems or any questions till now for loop. So in my list. Okay, guys. See, now there is a requirement to update each and every value, right? So post 10. See what is going to happen. What is this range? Okay, so range is again a new method. The use of range is that you provide a start, you provide a start, you provide a end, okay, and range which produce each and every number from start up to end minus 1. Okay, it is similar to that, including start and excluding the end, similar to that list slicing. Okay, or and each and every these element, these values were copied by I and printed by I, right? I think there are no doubt in this. Similar to list slicing, there is a start, end, and there is a jump. And from the given example, uh, it is pretty clear that default value for start is 0, right? And suppose if I don't provide anything, see what we will get. We will get an error. So there is no default value for a end. Range always require one value, at least one value, right? At least one value. And that value is considered for end, not for jump, not for start, for end. There is a default value for jump and that is nothing but 1. Okay, so now how to provide star. Now suppose I want a range, I want to print. Okay guys, just give me the code. I want to print each and every element from suppose 100 to 200 and the jump value is 3. Write the for loop for that. The jump value is 3, each and every element from 100 to 200, jump by 2. Okay, Okay, see, yeah, from 1 to 200 and jump value by 2, right? For I in range, what is the start value? That is 100. And we want value till 200. So the end value will be 201, right? And jump by 2. That's it. Mm, we just copy this print statement only, right? See, from 100 and the jump value is 2, all alternate elements, right? Up till 200. Okay. So provide a print here to break the line. We want two different lines. Okay. See, our requirement was to update each and every element, right, of my list. So again, using the for loop is only for our convention. Okay, it is only to ease our efforts. We are again going to use that old method. Suppose I told you that I want to update the zeroth index. Okay, zeroth zeroth index with the value by 1. So this is what we will perform, right? Okay. Instead of this, the shorthand method is only the plus equal to, right? Okay. So it is quite a hectic work to perform this for all 200 or 300 elements, whatever we have. So we use a range function, range, to get. So tell me, if suppose I have a list, so the indexing start from 0, 1, 2, 3, 4 up till length minus 1, right? The length of the that particular list minus 1. These many indexes are there, right? Inside a list. So what I is going to do, I is going to get the values of this index, that is 0, 1, 2, 3, 4 till length minus 1 using this range function. Okay, we have seen that the value of I is 0, 1, 2, 3, 4, 5, 6, 8, 9. This is nothing but we can use that values as an index. Okay, as an index to access. Now we are accessing each and every element of my list 1 using the index. Okay, and then we are updating each and every value by 1. So okay, just comment out this one. Each and every value is updated by 1, right? Oh, sorry. No, see, each and every, why now I have my list where we have my list. Okay, it is my list 2, right? Then again, these values are updated. Why did I have, yeah, this one, then this one? Okay, now it's correct. See, each and every value will be updated by 1. Instead of 0, 1, 2, 3, we are getting 1, 2, 3, 4, 5, something like this. Okay. See, in the last execution, we get 0, 1, 2, 3, 4, 5, 6 for this my list 2. Now instead of 0, 1, 2, 3, we are getting 1, 2, 3, 4, 5. One updated value. Okay, guys, just let me know if you have any doubt in this for loop. I will try to explain that in deep if you have any doubt. Or otherwise, we will move to enumerate and then tuple. Okay, so we have no doubts. See, when to use enumerate? What is the use of enumerate? For not elements, element in my list 2 print element. Suppose instead of 1, I will increase each and every value by 23. Okay. Now, if I will print, we will get the values, right? Whatever values those are. Let's end it with something like this. Okay. Right? But instead of this, I want the index of 24 and the value 24 itself. Okay. I need index of 24 and the value 24 itself. So use enumerate like this. Okay. For enumeration, we have to use two different variables. Okay. Two different variables in for loop. The first variable will contain the index. The second variable will contain the value. Okay. Suppose we have index and end it with space. Okay. Now it's good. See, the index of 24 is 0. The index of 25 is 1, something like that. So what enumerate do? Okay. Enumerate returns two things. Enumerate provides two things. First, the index number. Second, the element. That's it. Okay. That's it. Right? That is the only use of enumerate. Okay, guys. And let me know if you have any doubts till now for or in for loop. See, it is very important to understand for loop, right? We are going to use it now and then in each line. Okay, so we have no doubts. Now move to tuple. See, we have seen that a list always start with a square brackets. Okay, print type my list and it will print list. But a tuple, it won't. Yeah, a tuple is always written inside two small brackets. Okay, and tuples are immutable in nature. Let's first see how what is tuple. So this is similar to my list, right? It can okay, it can contain any values, right? You can give it a string or anything similar to list. Okay, there's nothing more, right? But if you want to change or update any values, see what we will get. We will get an error. Tuple object is not supported item assignment. Means you cannot update any value given inside a tuple, right? So this explains that tuple is of type immutable. It is of immutable type, right? You cannot change the value inside a tuple, right? So instead of my list, let's undo. Okay. Instead of updating the values, you can change in entirely change the tuple. That can be sorry, that is correct, but you cannot change a value inside a tuple. Okay, a value inside a tuple, a value of the tuple you cannot change, right? Okay, so so you cannot change a value. It means that you cannot perform any copy or anything. Means you can perform this copy operation. That is uh, okay. You cannot. Do we have a tuple on this? Yeah. So as assignment is not allowed in tuple, you cannot perform copy we have nothing like what you can say slicing. Okay, okay, and other than this, okay, we have slicing. Wait, see, there is a difference between using copy and using slicing, right? So we have seen that. Let me use. We have seen that whenever we use copy, what we are doing, we are creating a new memory location and moving something from here to here, right? Means we are writing something new inside a memory location. That's why copy is not allowed because we cannot write inside a tuple, inside a tuple. Okay, but why slicing is allowed? So what happens in slicing? Okay, just wait. Yeah, suppose we have a value 2 and we will perform get and see. Okay, those are not subscriptable. Let me print the IDs then. My tuple 2 and then print the ID of my tuple. See, both IDs are two different IDs. It means, see, suppose this is my tuple 1. What slicing will do? We define the starting and ending address, right? Suppose this is the starting index and this is the ending address. Okay, these many elements we will require. What slicing will do? It will just grab this much amount of memory, this much amount of memory. Okay, take aside that memory and rename it with mylist2. That is what slicing. It is not performing some write operation inside another memory. It is not writing anything one by one. Okay, it is taking a bunch of memory and just taking aside that memory. That's it. That is what slicing is doing. It's not writing anything, right? So that's why slicing is allowed, right? And we have seen that. Okay, sorry. Yeah, see now. So it is of type immutable. Then if I will try to, I think I have given that example. No, right? Try to assign some value. Then for this one we will get an error. Okay. All right. Just something like this. Tuples are immutable. Okay. Similar to strings. See, if I have a hello. Okay. And instead of h, I have some made some mistake. I have written q. Okay. I want an h there. So if I will change the first value like this, see what we will get. I've commented that out. Okay, yeah. See, we will get an error. String objects are not supported. Item assignment. Strings are also immutable. Okay, strings are also immutable. So while discussing about dot copy, I have told you that copy only works with mutable data types. Someone has asked that why copy doesn't work with string. So this is the reason. String is of immutable data type. If you have done some error or mistake in creating a string, just create that same variable with the correct value. That's it. There is no option of like updating that value. Okay. So we have seen tuple. Now see, tuples are immutable. It means you cannot take user data inside a tuple. If I have created my tuple and I have created an empty tuple, there is nothing inside this tuple, right? And if you will say that I will take some user data. Suppose I will take some input. Let me take my tuple at index 0. I will take some input from user. So this will surely throw an error. It is asking for some values and I will provide some value. See, tuple does not support item assignment, right? Why? Because we cannot provide any value to a tuple. So whenever you are creating tuple, it is bound to provide the value during creation. After that, you cannot add, cannot remove, cannot delete, cannot update a value inside a tuple, right? Okay, so that's it for the tuples. There is nothing more. Uh, Similar to for loop. Suppose you have my tuple with values like this. Then we have for loop, sorry, for I in my tuple, and then print the value of I. It is allowed to access, similar to for loop. L, what we have, that list, nothing new. Okay. Okay, guys. Any questions till now about tuple, list, for loop, anything? Okay, so no doubts. See, we have some list methods with us. What is this? One is insert. Okay, one is we have clear with us, and okay, just give me. Let me give you the. See, these many you have. You are okay. These are different methods in list. Okay, what are methods? We have seen that there are some predefined codes, right? We have seen that sum function, by using sum you can sum the each and every element of the list. So these are some list methods. Now, where we are, yeah, some of the important ones are, there are many methods in list. Okay, let's first see these. One of the very common one is, suppose I have a list and I want to add some new element, right? Let's take a user entry and we will provide this value, right? See what happens. First, let's print the length of my list. Then again print the length of my list. Then again print my list itself. See, yeah, add new. See, we first get the length of my list, that is 5. It is asking me to add the new element to the list. I want to add 100. See, now the current length of the list is 6 and the new element is inserted inside the list. Okay, so append, this append used to insert elements from back in the list. Okay, this one is important from the rear end, right? So see, one of the example is, instead of using here, let's use this. Yeah, suppose I have an empty list. So these are the methods to create an empty list. Both my list and my list 2 are empty lists, right? Both are empty list and both are valid. So let's create a code to take user input in a list. Okay, first create a size and int input, insert the size of list for I in range of n. Let's create a int input, insert element. Then we have my list dot append a. See, the first thing it is asking me for the size of the list. Suppose I want a list of size 5, then insert element. So I am inserting 50 elements. Okay, let me print. Yeah, execute again. See, it is first asking me the size of the list. Let it be 5. Then I am entering 5 elements, and we have created a list from user input which is having 5 elements provided by user, right? So this is how the role of for loop, the use of append method, how to create a empty list, okay, how to use user inputs to create a list of user size, right? So here you can observe that you can come to a conclusion that the size of a list is not fixed. Okay, you can insert as many elements you want inside the list, right? See, if I will do, sorry, and if now I will print my list, see what we will get. Okay, so it's asking me for a value, give it 100 again. See, for this first print statement, after this append, for this first print statement, we are getting an updated list. And after using this clear, we get an empty list. Clear is used to delete each and every element inside a list, right? Okay. Now, by using append, see, append is not a very, you can see that by using append, you can insert even a tree, a list, right? And if you will print my list, see, inside this my list, there is one new list is inserted, right? So first execute this one, and okay, so we are using clear, right? Remove this first. Now again run this. See, inside a list, we are inserting again a nested list, one more list using append, right? Okay. So clear and append you are going to use append very often, right? And now other than append we have leave the insert. Okay, let's see remove and pop. See the difference between remove and pop. Okay, now I have an empty one. Okay. So the last element in the list, currently in the list after appending a new list, we have 1, 2, 3, 4, right? Comment out these. Yeah, now it won't ask for the user input. So here we have the last element as the lists, right? Now what pop will do, it is nothing fancy, but it will only delete the last element, whatever is the last element. This whole list is the last element, so the pop will delete the whole list. That's it. Okay. Now see, why we are getting clear delete each and oh sorry, 0 is not inside the list, right? 1. Okay. See, by using remove, you can target any element inside the list and you can delete that specific targeted element only. Okay. See, I have targeted 1 and 1 is deleted. Okay. If suppose I have targeted, sorry, I have provided 4, then see, the 4 is deleted. The 4 is deleted, right? In the first case, when I am using 0, I get an error because 0 is not inside the list, right? 0 is not inside the list and we are giving a command to delete 0. That's why we are getting an error. Okay. So delete a particular element. See, there is a catch in this one. If I will append 4 again, print my list. See what will happen now. We have two 4s inside the list, right? But remove will delete only the first 4, the first encounter of the element. Only the first encounter of the element. See, I am passing 4 to delete to the remove function. It will delete only the first occurrence. Whenever it will encounter the first 4, it will only delete that 4 only. Okay. The remaining elements will be not deleted, right? Delete the first occurrence of a particular element. Okay. We have seen append, pop. So you have seen that the difference of pop and remove, right? Okay, let me tell you then insert. See, I will recommend you to uh, not use insert, okay? Because there are many more methods other than insert to achieve the same result. Why I am saying that insert is a very expensive method. By expensive, I mean it requires very long time to insert very large amount of it require very large amount of extra memory to insert even a single element. Okay, so if I have a my list, I want to insert in my list, and at index 0 I need value 100. Okay. Okay, so let me put here insert a value at particular index, and let me write the syntax. It is insert index comma value. See, this is our list. Okay, this is our list, and I have used a dot insert to insert a value at index 0. Index 0 is nothing but the first element, right? The first element. So it is inserting the value at index 0, that is 100. Now this is our new list. The list is updated. Okay. Then using the clear function, it will delete each and everything, right? And let me write the syntax here also, remove value or element. Right. For pop, there is no parameter is required. For append, the syntax will be append value, right? Okay. Insert. See, if I will insert a value at index number, suppose what is the index number? Yeah, 5 and 6, 5, right? Suppose I want to insert at index number 10 a value 800, right? And print my list. See what we will get. I have provided index number 8, right? But if you will see, this is nothing but index number 6. So this is a boundary case in insert. If you provide a particular index number larger than the size, larger than the actual index, okay, of the list, then the element will be inserted at the rear, at the last of the list. Okay. So in this case, index is larger, greater than the length of list. Okay. So if index is greater than the length of list, then the element will be inserted at the last. We are not getting any error. Okay. Okay. So there are many more methods. Okay. This clear, insert, and index. Okay. Let me tell you sort. I forgot the most important one. See, if I have a list with values, right? So if we want to sort this one, sort means arrange it in ascending or descending order. Just use the sort method and perform the sort. It will arrange each and every element inside the list for you. But there is a catch while using the sort method. Be very careful while using sort. Suppose if I will provide a string here, see what we will get. We will get an error. Why? So sort is a predefined method, right? Someone has written some logic behind this sort. See, someone has written some logic behind this sort. Okay, so the implementation will be somewhere else. So that logic is comparing the values inside the list, right? This 4 will be compared with this 5. This 4 will be compared with this 3. Something like that, okay? So tell me one thing before this sort. Suppose if you want to compare a string with an integer value, can we get an error? Yes, we will get an error. We cannot compare a string and an integer value. This same rule apply to the sort also. Okay, sort cannot compare a integer value and a string, right? So be careful that whatever stored inside your list, Sort cannot work for each and every element. Just if you have a boolean value, see, for a boolean value, it it will work. Okay, and it is not always provided. Suppose if I have a 0 here, so it will give you the values, and if you will place true anywhere in the list, something like this. Okay, then again it is placed. See, just observe this one. True is just placed after 0 and before 2, right? So I think you guys are aware with familiar with that bit manipulation and Boolean values. So true is considered as 1 and false is considered as 0. Okay, that's it. So be careful with using sort. Use sort when list contains similar type of data or comparable data, right? Suppose if I have a list, my string list with values low, then I have a A, then I have a B. Now you can use sort on this one, right? Now it is printing, it will print the strings in sorted order because it is okay to compare two strings for sorting, but not an integer and a string. Okay, so guys, consider it as your homework how to sort a given list in descending order. Okay, that's it for today. If you have any doubt, just let me know. Also, there are many more methods in list. Try to uh, just check how these methods work. We have seen copy, clear, pop, remove, append, insert, sort, reverse, and index is left. Okay, so no doubts. Okay, thank you everyone. That's it for today.
Thank you all for today's session, and let meet tomorrow at the same time. Thank you all.